And now for section 6.2, this is going to be addition and subtraction of vectors. And if you have two vectors or more, and you're trying to find a single vector, this is called finding the resultant vector. And the resultant vector has the same effects that the two or more original vectors would have. And so if we're adding vectors, we have to sort of understand what these vectors are now. I'm going to draw some, actually I'll just draw them with a pen. So if we have a vector here, again this should be straight, but if this is vector B, and then we have another vector here that's A, and you can do the full arrow, just remember, but sometimes it's faster just to do the half arrow. So if we have these two vectors, there is an important rule that we have to follow when we are adding or subtracting these vectors, and that is every single vectors, when you're trying to find the sum or the subtraction, they have to be head to tail. And so what does that mean? If we had a vector like this, sorry. Okay, so this side here, let me grab my pen again. This side will be the tail, and this side will be the head. So you cannot do a tail to tail. If you do, I'll show you which the only difference that you'll have to follow. So I just drew in here the solid vectors so that they're easy to work with. So if this is vector A, and this is vector B, if I put it like so, we have right here, we have a tail and a tail together. That's bad. You always want it to be head to tail. So if you then get vector B and you move it here, now we're okay. This one was vector A and this one was vector B. And so if you look here, we have an arrow and we have a dot making it head to tail. And so if we were trying to find, for example, A plus B, the resultant vector would be like so, a tail to a head. So if we did have the situation where we had a tail to tail, so here's A and here's B, what you can do is finish the parallelogram. And that would be saying, doing like so, and it should be straight. And so I'm going to call this U, for example. And if you were to complete it here, you can see that we have a parallelogram there. And if we were trying to find the resultant vector, now that we've completed the parallelogram, which our U is the same as our B, and if we're completing this and we were to come across like so, this vector in blue is a tail to a head, and so that is A plus U, which is the same. So if we have A plus U, well, we made a parallelogram, so that U is the same as A plus B. And so that's your vector addition. All right, so now if we're going to add parallel vectors, and so if we're going to add those, we can take, let me switch to this. All right, so we have this first one here. Oops, wrong one. So we have this vector here, and we have this vector here, where the first one is 10 kilometers per hour east, and the next one is 2 kilometers per hour west. So these are parallel vectors, but they are opposite directions. So if we take this one, and let's say we move it over here, and we put them in line, the vector that we are trying to figure out is the resultant vector, which is head to tail, which would be right here. And again, that should be straight and parallel, but because I'm writing, it's not. So that's what we're looking for. If this is 10 and this is 2, our resultant vector here will be 8 kilometers per hour, and the direction we are moving would be east. So in general down here, that if we have parallel vectors, which have opposite direction, where r is the resultant vector. So if the magnitude of A is bigger than the magnitude of B, then the resultant vector, which would be A minus B, and r has, whoops. So that would be the A minus the B. That would be the magnitude of the resultant. And the resultant r will have the same direction of A. Vice versa, if your B was bigger than your A, then your resultant vector r the value, the magnitude of it will be b minus a, and r, your resultant, has the same direction as b. So now if we move on to subtracting vectors is basically you want to use the opposite direction. And so, for example, if we had a, the vector a minus b, that's the same thing as doing the vector a plus the negative direction of the vector b. So if we had a vector like this that was b, and we had to subtract it from the a, that would just say take this, make it parallel. Those should be parallel. That would be the negative b. They need to have the same magnitude, just the opposite direction. And so that would be where the negative came from. And as a side note, if you add those two together, your b plus your negative b, this will give you the 0 vector. Oops. Let's highlight that so that we can know that term. So that's the 0 vector, and it has no specific direction. And we write it as 0. And so that's the end of the adding and subtracting vectors video. But in class, we'll be doing some examples, and you can do some practice homework from there. There's also going to be a mind map, which you'll have the chance to do. If you have questions, you can ask the next day.